Hey. Okay, so in this, you need to calculate mass. Is there something wrong with the volume? Maybe not. The diameter of the ball is given, diameter of the cylinder is given, and the height of the whole object is given. And the density, this is most probably steel. Big meter. Yeah. Here, for example, for sure, maybe you already did. It's 7,850 kilograms per cubic meter. Here is steel 7,830. So most probably steel. And how is this done then? I have here some Finnish Finnish text because I had this earlier told in Finnish. But the fair stuff you can find from the page 22. There's, for example, the volume of the sphere. So I had written there. Then I'm gonna instead English. So you have to know the volume of this sphere. The volume of the, what was the other cylinder? But then you have to take the little part that's inside there off, like away. And that's called segment of a sphere. So I could write here segment. Segment. And then that's how you end up calculating certain things. And then, so the sphere volume is easy, of course, because you can just find it here. You just have to know the radius, and that's, of course, half of the diameter, yeah? Diameter 1. And then also the volume of the cylinder is easy because it's the area of the bottom times the height. But now here you know the whole height, so then you have to make some calculations to get to that. And here I've picked some like equations that I found from this book because I'm used to using this book. And this is also, of course, what you have in the exam. So the segment of the sphere, for example, here, either these both, of course, do these equations, but I have picked this one there. It doesn't maybe make much difference. And then you have to somehow realize what it means. So this is, for example, is marked with this kind of rho. And then I have checked what is the rho. Well, here the rho for this little thing that you have to take off, you have to subtract this, which is the segment. Yes, the volume is here, and this obviously this that's marked in the equation book with the rho is this. So it's half of the diameter of the cylinder. So then the only thing now that I would need to know is the height here. And that I mark with height 2. Well, first of all, I would need to know this height. You know, height to the start of the cylinder, that I can solve this right triangle, obviously, because I can draw the radius of the sphere to the start of the cylinder here. And then I also know this because it's the radius of the cylinder. So here's the radius of the ball, here's the radius of the cylinder, and then I can solve this. So I marked it with this whatever rho, but it's also the R2, which is of course half of the diameter. So then I get something, but everybody has their own values, so I'm not gonna write any. But and then I calculate the volume of the segment. Volume of the segment. That was a bit more difficult thing. Then I would still need the height of this, the cylinder. And of course, the height of the cylinder I get when I diminish this. I take the part, for example, the diameter of the big ball, the ball, away from the whole height. So the height, if I write there, for example, the height of the cylinder, that would be height minus this D1 plus the height that I got for this. So that would be height 2. The height 2 I got, of course, from the height 2 for me was the radius of the ball minus the that I marked with X here. I marked that with X, the height to the until the that would be the X. So maybe this is a bit like it looks. That's just I try to use the letters that the equation book had used. So, but it's not like super complicated at all. It's just and then you have to figure out how to get the mass in grams from the kilograms per cubic meter. Okay. So then I'll take this there. So then I put it in the Excel because I thought this makes a lot more sense. And I just took the picture that had some numbers, but then now of course when I can calculate in the Excel, I can easily change the numbers there if it would happen that at first I got it wrong. So there, if my diameter would be, let's see, I could still pick what it gave me this time. It gave me 37, 16, and 82. Oops. No, it wants to. Okay. What do you want to do it like that? 7, 16, and 82. That was still 16. So then I started calculating with Excel. For sure, you've been doing this maybe a lot. I get, for example, this. Of course, the radius is half of the diameter. It's easy to get it there. Then the height, I marked the density, and then I marked this, whatever row that was the way the equation book marked the, how do you say the radius of the segment here, that marked with, so I marked it with row then there, and then so I call the X. And then I just have to pick these functions from the Excel. Are you familiar with using Excel now? Yeah. So you know how to do the square root, for example. You just pick it there and the power there. So it's this easy calculation there, the X, which was the radius of the sphere minus the radius of the cylinder, and both in power of 2 because of the Pythagorean theorem. Then I mark with 2 and I get this from the if I just did it. Oh, is this correct? Yes, E19. Yes, from the radius of the sphere, the X. Then I get this small height there. That was crucial for the this little segment that I had to remove in the calculation. And then I continued to the so the ball I can calculate easily with the equation that's in the equation book. And then you have to use this B, yes? So you just have brackets there for some reason. I don't know if you can put something inside there. I never seen anything inside there. I don't know why you have to put the brackets. Then the segment equation is a bit complicated, but that's just the thing from here. Yes. And then the ball minus segment, then the height of this. Well, I put pipe, cylinder, volume, and the whole volume. So this was where I finally made a mistake. I didn't calculate together those volume of the sphere and the volume of the cylinder. But then I checked from the ChatGPT. So it calculated everything correctly. So I could just check the numbers and then I checked, okay, well, I just used the volume of the pipe or the cylinder there. And then I got, of course, the mass was a lot lower than it was supposed to be. Okay, so now when I have this now like this in Excel, it already rounds it to me here as well. And then I can just put it there. Oops. Yes, everything should be with the correct numbers now. And then I just say that A is correct. It'll trace. But yeah, this is in Finnish now. Sorry about that. It's correct now. Yes, so this calculates correctly. What do you think about this kind of a calculation, for example? Do you think it's difficult?
When you do it, it looks very easy, but then when I try to do it,
Yeah, but then it's actually good to also have the friend, because then if you actually use it the way that you think yourself, and then you just ask like, okay, now it's not correct this. Where did I do wrong? And then you go through and then it's like, hey, so then you actually learn as well. If you just ask the number from the obviously you don't learn anything. You just realize that, okay, it calculates this kind of things nowadays really easily as well. Okay, but okay, if you want to ask from some you can ask. I could try to calculate some a bit even more difficult. Forex. Hihna. Okay, let's just take this because it calculates correctly. This is yeah, now I have to change the language still. For some reason, this is always in Finnish when I start. This. Did you do this? Yes. That's difficult for me of all of these when I first calculated them. That's just like it was difficult to comprehend like. So how do you call this thingy?
But
The whole thing?
bell, kind of thing, slightly. But
Yeah, but because we have to. Yeah, belt. Red belt length. So if I know the diameters and the distance between the centers, how do I know the length of the belt? This here. And then I have to go here. Then it still goes round here. Oops. And round here. Hey.
somehow appears that if you have a tangent lines like you do, from the big circle to the small circle on the same side, that the tangent point on each circle, is mitigated through the circle. Or is it?
Well, I have I have one type of solution to this. And maybe the ChatGPT can give you another type. But this is because I know the diameter for both. I know diameter 1, which is it would be 304. I know diameter 2 also, which is 174. From where I know the radius is. And then I can draw the radius here. But I would need to be a bit careful how to draw it so that it looks correct. So this is the length that I know. And then I can draw the same thing here. So I can draw here this radius, and I can make it the way that this is a rectangle. So there would be a rectangle there.
Okay, exactly what I meant.
Is this exactly what you meant? Okay.
Yeah,
Then you are very clever. Yes.
but drawing the tangent line, from the top of both circles. Why or how is it like exactly in the middle of the circle? How do you like justify? Or what makes it happen?
That is exactly tangent line, like you mean this
Yeah,
in the middle of the circle.
yeah. Like,
It's not just there. Anyway, there's from the center of the circle to the edge of the circle, how do you say, to the arc?
yeah,
There's always the same distance. And then this yeah, how do you know that actually this thingy there is still there? You mean the belt?
yeah.
How do you know that the belt is not?
Like if you
Mm.
draw the opposite radius line, it does coincide lower tangent line, yes.
Yes, so draw it with the same angle here. That's a good question, but it's like I assume that it's the same angle because I can also see that. Like, can I see something? I don't know.
That line you just drew.
Because this makes sense. Here it has to go on the circle, yeah.
Okay, so it's not.
It has to go, but here, why is it touching this?
Yeah,
That's a good question.
it's not a straight line, the radius lines inside the circle, is it?
It's not straight to here. It's a bit bent so that I'm able to draw the rectangle.
Okay.
That here like this. Straight angles everywhere. Yeah. So now I know this I know the distance, which was the distance between the wheel centers that I have can mark with whatever. Well, anyhow, I know it. 310. This I know. And of course, then this I know as well because it was the radius of the smaller circle.
Okay.
Which would $87. Or for example, in this is so this whole thingy here was the diameter 2 is 87. So then this part here, I use some other color. This part here then is the 87 minus the what was this 152. You can't see it. 150. Sorry, the 152 minus 87, of course. Not 87 minus 152. Yeah, but it's a good question. Why does this touch this here? Mm.
Yeah. Open, so, terrible.
Yeah,
Right.
yeah, it's not exactly on the top, but it's a bit bent, and we still assume it to be there.
Yeah.
Mm. That's a good question.
And the okay.
How do I use my dear Excel? Now I have to find, I calculated this somewhere. I think. No, did I calculate it by hand? Oh, I've been brave. So let's calculate it here. No, why don't you let me to have another other? No. Something wrong with this. My Excel. I have to take another. Okay, let's take another then. Now it wants me. Now it gets me. I can get an. Okay, I will first cut it. Cut it. Wait. To move this away. No. Okay, like that. So then I start E1. Well, I don't know if I need the unit here. Usually you should always put the units as well, I think, in the physics. Maybe you learned. Because I think this is all just in millimeters. Then I put the R1. Two. Oops. Then I put the distance. I can write it distance. For example, that was now 310, which is millimeters. Then I start with the how do I mark that? Well, I just mark it with the R1 is R2, sorry, because it's R1 minus R2. Hmm? And now I can write there, now in my calculation, this is 65. Then I put there that one. And this is what I didn't know. Now this could be, for example, my famous X. X. This could be a bit. And now this is with the. So I know that here is my straight angle here now. So then this X is the, well, I can write it here as well first. So my X is the square root of the 310. That seems to be the hypotenuse minus the 65. That. $310 minus 65. So now I know this distance here, this distance, which it's always the X. So that's also the X, and this is also the X. Do you think this makes sense? There was only one question. How do we know that they did it well to the here? Well, this was now with these numbers, this. Then I have to know these lengths here. So I know that there's two of the X's and only these lengths are still done. Not that I didn't know, but it's fairly easy because there is a equation for this in my lovely book. Where is it there? So that was the difficult part. I'm there with the easy part. And maybe some of you already know, like in the circle, this length here, you can just take with the, you have to know the angle there basically, because the whole circle, what is the word for that? Round the whole circle. Circumference. Is the P 2p or p 2p times OP diameter. And then you can just, if you know the angle there, then you can calculate the length of the arc. So this is then fairly easy. So we have to know the angle here, this angle here, yeah. And we can mark it now with the famous alpha, for example. So my alpha there, or I can just start writing, for example, with these numbers that I know the accurate numbers. So I know the distance, I know the this length and this length with accurate numbers or whatever. So thinking. Yeah, and this is the hypotenuse, yes. So it's the one that's next to it, which is cosine. Cosine is this now my 65 divided by the 310 hypotenuse, from which I get the alpha is cos minus 1 this. The 65 divided by the 310. Yeah, and then I have to know how to write it to the Excel. Okay, I'll just write it here because I don't, maybe I can get it from here. Symbol. This is that I found the closest to the alpha. So it's the cos. Cos. And then I can take 65 divided the 310, which is the distance. And then I still get this now in radianit, don't I? So I have to put one more command. Have you done this earlier? This kind of a functions with Excel. So now if I put something here, I take this, it's something weird. It's in radians, okay? So I have to put one more command there, and it's the decrease. So it makes it the decrease. I already have here one bracket. Does this look complicated? Did you ever do something like this with Excel?
Inverting.
What?
Inverting degrees radii.
Yes.
Yeah. Right.
With Jaakko.
Yeah. But we did like degrees, the radians, and back to degrees. And always confused me.
Yeah. So here I'm just calculating one angle. And I realized that I can calculate it with a cosine. So to get the angle, I need the inverse function of cos. But now it gives me it's in radians, to explain it in radians, yes? to put it to degrees, I need one more command there, one more function. How do you say? To degrees and the brackets. And then I get it, this angle alpha in degrees. Maybe you're calculating some other exercise now. Or are you calculating this?
Understand why. See, you have 65. Why is that 65? Like, I understand that you've taken the number away, but I don't understand.
Why is it that? Because it's 65 because this length from the diameter, yeah? So if I
Oh, okay.
if I make this trick that I turn it a bit and I make a rectangle, I know that it's here, and that was the 87.
Yeah.
So this is 87 in both. Here in my picture, now this would be the 87. Here it would be also 87.
Yeah.
And then I knew also that the whole radius one was 152. So if I take it this 87, I subtract the 87 from the 152, I get 65.
Yeah.
And now I know that these angles are straight, I can calculate.
Yeah, no, I understand.
And the only question here was to be asked was that, is this actually correct? And does this belt actually touch this so where does it actually go? Does it go to here? It's not like, you know, straight here. It's a bit like tilted. Does the belt actually touch it here? Well, it looks like it does. Do you think that these exercises are difficult or easy?
No, it doesn't seem quite easy, and then others seem hard.
Yes,
Do that.
I wouldn't have either.
Then I don't know what everyone is.
And then this gets even more complicated because now I can't just give you the points of these, but I still have to put something in the exam, and it has to be something complicated as well because of the AI. Earlier on, this section would have been done with these exercises. And then that's like done. And
We do geometry and exam.
yeah, because you can just ask these
Yeah.
answers from the AI and put them there, and yes, that's the problem now. Okay, now I know the alpha here. So then this here is also the alpha. So I know that this angle here is 2 times the alpha, yes? And also this angle here is 2 times the alpha. So here I have 2 alpha, and also here I have the alpha. So I got something there, 77.222. Then I get the 2 alpha is 2 alpha. I'm not always so keen on Excel because I think it's not really easy to use always. Well, but it's the program that you always use at work. Yes.
It's a bit hard to have
an English keyboard than a Finnish keyboard.
Okay.
All this difference is like, you know, I have to try and remember.
Yes. Okay, so now I know the 2 alpha is something. Okay, this is about 150.7 something. And now I just know this. The equation for this B here. This. And here's the equation. And it comes from, I can just write it there. This, I can mark it with B there. This is like the angle here that I have, which would be now 2 alpha, because I marked it with alpha. But my 2 and my alpha look exactly the same. Divided by the whole circle times the if I go do it with the D, I do it with the R, 2PR. The whole length of the circumference. And then of course I can do it. So there would be still my 2 alpha, and here would be 180 and just the PR. If I take away the 2, you know, so what was the word for that? It's just like the equation here. Yes. Okay, so then my B here and here I have to, so my B here, that would be, for example, B2. B2 is that 2 alpha 180 times PR, which is my 2 alpha 155.7. PR. And then my B1, that would be my B2 here. Here the B1, if this one was my, then is the $360 minus the 2 alpha. Yes, because this is what is left, yeah. Divided by 180 times. And then I can do these calculations in Excel. So I put here the B1 is this divided by 360 times B. Oops, like that. Times this. Yeah, and of course I have to put there the R, which should be the R1. Would be the R2. No, now I'm putting it the wrong way. But why did I? This is the R2. R2, this was the 2. And this is the R1. This was the R2, and this is not B1. Okay, I'll do the B2 first. 2. Okay, does it look? Yes. And then the B1 would be the 60 minus 2 alpha divided by 360 times B. B times R1. And now I have everything that I need. Length. No, this is the wrong way. Length. Two times X plus B2 and B1 plus, oops, what did I do? And then I would get it there. And this is all millimeters. And then I have to round it. Right. Now it shows me this. Ha. Excel is nice. It can even round you that stuff. It's not a long calculation in Excel. Hopefully, then I have to try if I got it correctly. Yeah, no.
You're drawing
Mm-hmm.
this red part. Is a sector of a circle.
Which?
That is just above the lens. You're right. You're right.
This?
No.
No, right.
Yeah.
This?
That is that center of a circle.
This is the B. I marked it with B because my equations books marks
Yeah.
it with B.
Part of the circle. If you draw a pizza slice, it's called the sector.
Yeah, pizza slice.
Yeah.
Yeah, that's true. But it's the length of the edge of the pizza slice.
Yeah. I think hopefully will mention the name of that.
Does it mention the name of that? It mentions that there's a circle and then it says B. So
Doesn't say sector. Because that's kind of
length of the edge of the sector. How would you use this?
Oh, I looked at the next page. I think that's what I was getting.
Yeah, this is also, you can also find it from here, sector of a circle.
somewhere.
And then
Okay.
you find the same equation also here. But what is the length B called? It's like something.
Yeah.
This is something that you need also when you make the sector to cone. In one exercise, you bend this kind of a circle into a cone. Did you do this kind of exercise yet? It's also in these a bit demanding ones. So there you need to know the length, this length, because then I think what you needed to know there was the volume. And of course, to calculate the volume, you need the area of the bottom circle. And there you get with the B, you first get this circumference of this from you then solve the radius. Easily. So you had to first, because you need the volume of this there, and then from the volume you had to, no volume, the area, you had to then calculate the B first, this. So this B is actually very important to know here in these calculations that we don't know what it's called, but it's the B. Yes, whatever. I was the most important thing, which was to try that if I calculated correctly with my Excel. And I have the same numbers there. So then I put there, this is in millimeters. So I can just put it 995 there. Submit. Incorrect. Now I calculated something incorrect here. It's so easy to make some mistake. Oh, I'm missing something now because this is a lot shorter. Or I calculated something wrong. So then I have to start checking. And now I could do it with the AI. So I give this to yeah, it's there already. It's exactly the same. And then I would take my friend. Where's my friend there? I asked this. Then I would ask, could you resolve this? I put it there. And then I can check what I did wrong. But it might take a little time. Most probably it does it the same way. I didn't actually ask this yet, even once, so let's see how this does it. Oh, standard formula. To see. Open belt drive as picture. Big pulley, small pulley. Center distance. Oh, it didn't do it with. Maybe it did something more a bit. Yeah. So you first calculated that. But then you can always ask that, could you do this? Could you do this? Like step by step. Step, which means that you get like a bit more steps. Maybe it does a different way. T. Center distance. 2 times center distance. Okay, it does it some other way. Maybe this is even better. Compute P times D plus D. Oh. But it doesn't. Now this gets a bit difficult, at least for me, because I didn't do it this way. At the parts, and it gets exactly the same answer. But now 85, it gets actually 84. Then the problem with this is not it doesn't draw you a picture how it did it. Can you draw me a picture? But this is the problem with the pictures. It doesn't draw them really well. To show how you did this. What do you think? Should we still do these geometry exercises next lesson and then go to the next subject? Would that make sense? Because it's not like we did that many. Or do you think that you will do them easily with the help of the friend at home?
Yeah, it's ChatGPT.
What?
Okay. What is the next? The
next topic is this. Now the pictures might be whatever. Did I have it here? Right, at least for me, when I ask the pictures, they might be like really, really bad. I have to check this still, but I managed, when I calculated by hand, I got the correct answer. Now I have to check my calculations. Yes, exponential and logarithmic functions, trigonometric functions. We still have 2 weeks for this topic, and then the reset and the exam on the same week. Here's actually a lot of material that some have did. But here it's only that we calculate by hand and then we calculate by hand also in the exam. I don't have any stack for this.
Yeah.
But now we had like one less lesson for this topic because I was sick.
Yeah.
So should we still continue with one more? Where?
Yeah. Yeah.
Okay, let's do one more, and if you have some good solutions for these, you can show them, even if you ask them from the friend, if you can explain them.
Everyone.
One more lesson. I try to do this here and you try to do, and then we can discuss about them and then we go to the next topic. Yes. Okay, good. Now I have to check my calculations at home.